Hi class. In this lecture here, we're going to talk about the graph of the cosine function. And so in this lecture is going to be a continuation of the previous lecture where I talked about how you do the graph of the sine function. And if you're skipping ahead or you stumbled across this video before watching that one, there's a lot of information in that one that lays the groundwork for this one here. So this is a continuation of that lecture. All right, so you're going to notice that as I go through this, this concept of graphing the cosine function is going to be like the same exact concepts that we use to graph the sine function. All right, once you read the unit circle, and you're going to hear me say this a lot. Once you find the 5 key points, it's actually really straightforward. All right, so let's look at this one. So let's find the graph of the cosine function. So y is equal to cosine of x. All right, and let's just do this on from 0 to 2 pi, okay? So just one rotation around the unit circle here. Okay, so if you look here in the unit circle, the x value is the value of the cosine function on the points of the unit circle here, okay? So going around, we know, just as a refresher, right? We know the domain of cosine is all real numbers. Okay, but we're just looking from 0 to 2 pi. And the range, if you look at the values of cosine, it looks like they're all between -1 and 1. So the range here is -1 to 1. All right, so again, what you're going to do to just sketch this very simple graph is you're going to find the 5 key points. Okay, and then you're going to notice we're going to do a bunch of examples in this lecture, obviously, just like the previous one. And when you find the 5 key points, the graph just goes boom, 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 and it becomes very straightforward. So, all right, so we're going to pick our x values, and we're going to plug it in to get y. And if you look over here, we're going to pick the same x values that we did for the sine graph. So we're going to do 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. Okay, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, so just like we did with the sine graph. So all you're going to do now is you're going to take this and you're literally just going to plug it in. So you get y is equal to cosine of 0. Well, let's see what cosine of 0 is. Boom, it's 1. So look, now we're going to start to get, these points. So our first point here is 0, 1. So now let's plug in pi over 2. So cosine of pi over 2. Pi over 2 right here, it looks like the value of cosine is 0. Now let's plug in pi. So let's look at pi. So cosine is -1. So our next point here is pi, -1. And look, what you're seeing here is a little different, right? Sine started at 0. This one's going 1, 0, -1. Let's see what this next one is. Y is equal to cosine of 3 pi over 2. Well, what is cosine of 3 pi over 2? So the unit circle, it's 0. So my next point is 3 pi over 2, 0. And then the last one, y is equal to cosine of 2 pi. So we're going one full rotation around the unit circle, cosine is 1. So my next test point, or my next point on the graph is 2 pi, 1. So look how this one goes. This one goes 1, 0, -1, 0, 1, right? So we saw, sine went 0, 1, 0, -1, 0. So this one is just a little different here. All right, so now let's sketch the graph using these points. All right, so it's going to go 0, then we're going to have pi over 2, and then we're going to have pi, then we're going to have 3 pi over 2, and then we're going to have 2 pi. And it's going to go from all the way up to 1, and then down to -1. So look here, 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and then 2 pi, 1. And then remember, when you sketch these graphs, nice smooth curves. Don't draw straight lines. It's not a V, okay? And that right there is what our cosine graph looks like from 0 to 2 pi. All right, so not bad. So again, you're going to find the key points, and it's going to fall right into place. So what I have here is a little bit more of a full graph of it, so you can see, you know, with more test points from the unit circle, how you get this nice smooth curve here. And then again, you know, I said, you know, the domain is all real numbers, and this is a periodic function, so it's just going to repeat. And let's grab our trusty calculator here, just so you can kind of see what this graph looks like, right? So if you go y cosine of x, and you can see this is, you know, what I drew here was this first period of it basically, and you can see it starts at 1 and like that. Okay. All right. So these graphs, the sine and cosine graphs are what are called sinusoidal graphs. So the graphs of sine functions and cosine functions are called sinusoidal graphs. So the graph of y is equal to cosine of x is actually just the graph of sine of x, all right, with a phase shift of pi over 2, right? So you can see here cosine of x is equal to the sine graph with a phase shift of pi over 2. It's literally just like moving it back a little there. All right, somewhat useful to know, but we're going to focus just on this cosine graph here, and how we're going to sketch that. All right. So here's some important information. This is very, very similar. It's actually the same as the sine graph. Okay. So the graph of y is equal to a times cosine of bx. Okay. All right. So sketching this graph here. All right. It has amplitude. All right. This graph of y is equal to a cosine of bx with b greater than 0 has amplitude, just like the sine graph of the absolute value of a, in its period. All right, the period, so how long it takes to repeat itself. Again, you're just going to take 2 pi and divide it by b. So just like we did for sine. And then all you're going to do to graph these variations here, and then just find the 5 key points. Okay, once you find the 5 key points, you're going to notice it's going to go boom, boom, boom. It's going to fall right into place very, very easily. Okay, so let's do 2 examples of, basically this is what we're going to do. We're going to do 2 examples of y is equal to a cosine of bx, and then I'll do 2 examples with a phase shift, and then I'm going to have one final example with a vertical shift. Okay, so this will be the first example. Let's sketch the graph of, let's look at y is equal to, let's do 3 times cosine of 1/4 x, and let's look on from 0 to 16 pi. Okay, 0 to 16 pi. All right, so just looking at this value in front here, this 3 is my a, okay, and this is my b right here. So let's go through this. What's the amplitude? It's equal to the absolute value of a, which is the absolute value of 3. So 3. So it's gonna stretch it a little bit. So instead of going from -1 to 1, it's gonna go from -3 to 3. All right, now my period. that's 2 pi over b. So that's 2 pi divided by 1/4. So keep change flip. So this ends up being 2 pi times 4. So my period now is 8 pi. Okay, 8 pi. So if you remember then, in the previous lecture, what we were doing next, all right, was we were finding quarter periods. All right, this helps us set up the 5 key points. Okay, so you're going to take this period you just found, 8 pi, and divide it by 4 to get 2 pi. Okay, so there's a quarter period every 2 pi. And then here there's no phase shift yet. We're not doing any phase shift. Okay. All right, so we've got the period, the amplitude, the period, and the quarter periods. All right, what you're going to do next then is you're just going to find the key points. Okay. All right, so you're going to start at 0. So without a phase shift, okay, without a phase shift, you're just going to start at 0. Okay, you're going to start at 0. Okay, when there's a phase shift, it's going to change, but for now we're going to start at 0. And then what you do is you start adding these quarter periods. So then 0 plus 2 pi. My next key point is 2 pi. Then you're going to take 2 pi and add another 2 pi to get 4 pi. Then you can take 4 pi and add another quarter period. And then finally, you're going to take that 6 pi and add 2 pi to get 8 pi. And this is what's amazing. You're going to notice when you start doing this that you're just going to, when you plug in these new quarter periods to what's inside the cosine function, you end up just getting back to cosine of 0, cosine of pi over 2, cosine of pi, cosine of 3 pi over 2, cosine of 2 pi every time if you do it correctly. So this ends up just being 3 times cosine of 0, because 0, when you plug in 0 for x here, you get 1/4 times 0, 0. So this is just 3. And then remember, cosine of 0 is 1. So my first point here my first test point is 0, comma 3. Now I'm going to take 2 pi. So this is 1/4 times 2 pi. Well, what is that? That's pi over 2, okay? And what is cosine of pi over 2? It's 0. So then my next one here, my next point is 2 pi, comma 0. And then you're just going to keep going. Y is equal to 3 times cosine of 1/4 times 4 pi. So that's just cosine of pi, right? And what is cosine of pi? You know, if you need to go back, okay? Cosine of pi, boom, is -1. So this is -3. So my next test point is 4 pi -3. Let's keep going. Got 2 more to do. Y is equal to 3 times cosine of 1/4 times 6 pi. Well, that's 3 pi over 2. Well, cosine of 3 pi over 2 is 0. Boom. So my next test point is 6 pi, comma 0. And then finally, y is equal to 3 cosine of 1/4 times 8 pi. Well, that's cosine of 2 pi, so that's 1. So 3 times 1 gets me 3. So my final point here of my 5 key points here is 8 pi, comma 3. All right, now remember, I wanted to go from 0 to 16 pi. So basically what's going on here is I'm asking you to graph 2 periods, okay? So let's take these points here, and then you're going to see the pattern, all right? So now I'm going to go to the next slide here and show you, show you what the graph looks like. So this was y is equal to 3 times cosine of 1/4 x, and we were going on 0 to 16 pi. Okay, so remember the amplitude was 3. So we're going to go up to 1, 2, 3, and then the graph goes down to 1, 2, -3. Plot the points along the x-axis. 0, 2 pi, 4 pi, 6 pi, 8 pi, and then you can see the pattern to keep going. Here's 0, 2 pi, 4 pi, 6 pi, 8 pi. Remember, you want to go to 16 pi, 10 pi, 12 pi, 14 pi, 16 pi. All right, so the first point here, 3, 0, -3, 0, 3. So 3, 0, -3, 0, 3. So you can see, here's what the first part looks, the first iteration of it. And then it's just going to repeat itself. And we got it. Looks like the letter W. But we got our first one here. All right, so it looked crazy, right? It looked rather difficult, but like what if you just follow the procedure? All right, stick with it. Follow the procedure. Hopefully it's not too bad. Okay, let's do another one. All right, and this one I'm going to do. This one's interesting. All right, you're going to notice something's going to happen with the pi, and well, you'll see when we get to it. All right, so here's the next one. Let's sketch the graph of let's look at y is equal to -4 times cosine, and now this is interesting, pi times x. So in every problem I've done, it's always been like 2, 1/2, 4, 1/4. But now I'm putting pi in front of x. Okay, that's still the value of b. Okay? And we're going to do this on -2 to 2. All right. Follow through. Trust the process here. Okay? This is my A. This is my B. All right, so the amplitude. That's the absolute value of A. So that's the absolute value of -4. So the amplitude is 4. Okay, so it's still going to go, the graph is going to go, instead of going from -1 to 1, it's going to go from -4 to 4. Now the period. This is weird. Okay, so I'm going to take 2 pi and divide it by b. So again, this is my b. So it's 2 pi divided by pi, which is just 2. And that's okay. Whenever you have this pi in here for b, you're going to just get this number here. And it's okay. Just still follow the process. So the quarter period, you're going to take 2 divided by 4, and you get 1/2. And then again, no phase shift. All right, so we're going to now find the key points. So again, no phase shift. So your x you're going to start at 0. All right. And then you're just going to start adding quarter periods. So you're going to take 0 plus 1/2. You get 1/2. 1/2 plus 1/2. You get 1. 1 plus 1/2. You get 3/2. And then 3/2 plus 1/2. You get 4/2, which is just 2. Now this is awesome because when you plug these in for x, you get 0, 1/2 pi, pi, 3/2 pi, 2 pi, and you get back to the key values that we wanted, right? So this is y is equal to -4 times cosine of 0. So this is -4 times 1, which is -4. Right, so my first point to plot is 0, -4. Y is equal to -4 times cosine. When you plug 1/2 in, you get 1/2 pi. And what is cosine of 1/2 pi, right? That's 0, or pi over 2, it's 0. So my next point I'm going to plot is 0, or 1/2, 0. So when you plug 1 in, 1 for x, right, you just get pi. All right, well, what is cosine? Cosine of pi is -1. So this is 4 times -1, which is 4. So you have the point 1, 4. 3 over 2. So this is cosine of 3 pi over 2. Well, what is cosine of 3 pi over 2? That's 0. And then finally, this is y is equal to -4 times cosine of 2 pi now. Well, cosine of 2 pi is 1, so this is -4 times 1. It gives me -4. So my next test point is 2, -4. And look, that's okay. That is okay. Whenever you have this pi in front of it, all right, your x values are always just going to be real numbers like that. Well, obviously, even if it was a fraction, a real number that does not include pi. Let me make that known here. Okay. So now let's plot. So remember, I want to go from -2 to 2. All right, and so I've got 0 to 2 on this side. So let me plot that, and then we'll show what the other side looks like. So we're going to sketch y is equal to -4 times cosine of pi x, and we're doing this from -2 to 2. So remember the amplitude is 4, so you got to go up to 4. And you got to go down to -4. And then look, 0, 1/2, 1, 3/2, 2. And then you're going to put the same values on the other side here because you want to go down to -2, all right, but just negative. So it's going to be -1/2. -1. -3/2. -2. So now look, the negative in front here flipped it, okay? So it's going to go -4, 0, 4, 0, -4. So -4, 0, 4, 0, -4. And then look, same thing on the other side. The pattern is going to repeat, okay? because this is an even function. Like that. And look, if it helps, right? If you even want to like just confirm this in our calculator here, right? So -4 times cosine of pi x, you can see the pattern, right? You can see exactly what I drew here. And look, you can go out to 2. You can see it goes down here. You go out to -2 down here. We've got it perfectly. All right. Now I know it's a lot to swallow here. Now let's do phase shifts. Okay. All right, and you can see here I have just a cleaner version of this here. All right, phase shifts. All right. So the graph of y is equal to a times cosine of bx. Now, whenever you have this minus c in here, okay, whenever you see something like this, you're going to know you're going to have a phase shift. All right. Is obtained by horizontally shifting, so horizontally moving it this way. The graph of y is equal to a cosine of bx, so that the starting point of the circle is shifted from x is equal to 0. So the new starting point is x is equal to c divided by b, okay? New starting point. All right, so if c divided by b is greater than 0, you shift to the right. If c divided by b is less than 0, you shift to the left. And this number c divided by b, this is called the phase shift, okay? So we have amplitude, period, and now phase shift. Okay. So let's do 2 examples of this. All right. So we'll start with a pretty straightforward one. So let's sketch one period. So only one period of, let's do this one. Y is equal to 3 times cosine of 2x minus pi. All right, this is my A. This 2 in front is my B. And because I have the minus here, this is my C. Okay, it's pi. So if it helps you to do this, right, just like A is equal to 3, B is equal to 2, C is equal to pi, you can just put those right in there, okay? All right, amplitude. This is equal to the absolute value of A, which is the absolute value of 3, which is 3. Period. That's 2 pi divided by b, which is 2 pi divided by 2, which is just pi. Okay, then next, what helps us find the 5 key points? You got to find the quarter period. So this is going to be just pi divided by 4. And then yes, absolutely, we got it. We got a phase shift here. So this is just c divided by b, which is just pi divided by 2. Now, you're going to notice here, this is important, and this is just a tip to help you. Do you notice how the quarter period has a denominator of 4, but your phase shift has a denominator of 2? It really helps. It really, really helps to have them have the same denominator when you're doing this. So I'm going to just write pi over 2. It's the same thing as 2 pi over 4. Okay, so now quarter period and phase shift have same denominator. All right, so to help find the 5 key points, have quarter period and phase shift the same denominator. Okay. So on the next slide, what I'm going to do is I'm going to find the 5 key points, right? And here, the 5 key points, you're going to start at this new phase shift, okay? All right, so start this, and then we're going to add quarter periods. So again, we're going to sketch one period of y is equal to 3 times cosine of 2x minus pi. Okay, so we started with 2 pi over 4, okay, which is really pi over 2, but trust me that this helps. Okay, then you're going to add quarter periods. Then you'll see why. 2 pi over 4 plus pi over 4 gets me 3 pi over 4. Then you're going to take 3 pi over 4. You see, now it's easier that they all have the same denominator. Plus pi over 4 gets me 4 pi over 4. And I'm going to leave these unreduced until I go to graph them. Okay, then watch. 4 pi over 4 plus another pi over 4 gets me 5 pi over 4. And then 5 pi over 4 plus pi over 4 gets me 6 pi over 4, which is 3 pi over 2. All right, but look, here's the deal. When you plug these in, right? Yeah, remember, you're going to end up getting cosine of 0, cosine of pi over 2, cosine of pi, cosine of 3 pi over 2, cosine of 2 pi. Just boom, boom, boom. So this becomes 3 times cosine of 0, which is 3 times 1, which is 3. That's why, like, once you set up these, you can just immediately go 0, pi over 2, pi, 3 pi over 2, 2 pi. Like, you could, if you plug in 2 pi into this, right? Like 2 pi over 4 times 2 gets me 4 pi over 4, which is pi. Pi minus pi, 0. So this reduced, just so we're clear, is pi over 2 comma 3. So now I'm just reducing it. So when I go to plot it, I'll plot the reduced ones. So this is 3 times cosine of pi over 2, which is 3 times 0, which is 0. So my next test point is 3 pi over 4 comma 0. This is y is equal to 3 times cosine of, this ends up just being pi when you plug it in, right? Because 4 pi over 4, is just pi. 2 pi minus pi, obviously just pi. Okay, so this is 3 times negative 1, which is negative 3. So this simplified, I'm going to put as pi comma negative 3. This is 3 times cosine of 3 pi over 2, which is 3 times 0, which is 0. So my next test point is 5 pi over 4 comma 0. And then finally, y is equal to 3. This ends up being cosine of 2 pi when you plug it in. This is 3 times 1, which is 3. So this simplified, just so we're clear, is 3 pi over 2, comma 3. All right, a lot. I know it's a lot. All right, so now we're ready to sketch this graph here. Okay. All right, so we're going to sketch one period of. So we got y is equal to 3 times cosine of 2x minus pi. So amplitude is 3. So we're going to go up to 3, down to -3. And then look, pi over 2, 3 pi over 4, pi, 5 pi over 4, 5 pi over 4, 3 pi over 2. -3, 0, 3. So 3, 0, -3, 0, and 3. And then a nice smooth curve through it. Like that. All right, I know it's not the easiest, okay? But we're getting there, okay? We're getting there. All right, let's do one more to make sure we have it, okay? So let's do this one. Let's sketch the graph. Sketch 2 periods. So now instead of 1 period, I want 2 periods. So sketch 2 periods of, let's do y is equal to 1/2 times cosine of 1/2 x plus pi over 2. Okay, so what this problem always does, and you gotta be mindful of these because like it's trying to trick you. Do you see this plus sign here? It always has to be rewritten as bx minus here. So this is cosine of 1/2 x minus pi over 2. So then that means this is my A, this is my B, this is my C. Okay? All right, so the amplitude. It's the absolute value of A, which is the absolute value of 1/2, which is just 1/2. Okay, so this graph is just going to go from -1/2 to 1/2 here. Now my period. Okay, that's 2 pi divided by b. This is 2 pi divided by 1/2. So this becomes 2 pi times 2, which ends up just being 4 pi. This is going to work out very nicely, you'll see. Then the quarter period. You're just going to take 4 pi and divide it by 4. This is nice. So this is just pi. And now look, because we have this phase shift now, okay? Okay, it's just C divided by B. So that's -1/2, or negative pi over 2 divided by B, which is 1/2. So when you keep change flip here, right, you know, this becomes a 2, cancels with this 2. So my phase shift, my new starting point, is just negative pi. All right, we're doing it. Okay, so we got our new starting point. We got our quarter periods. You know, we know that the period is 4 pi. We got this. All right. So this is going to be my new starting point when I go to find the 5 key points. Okay. So we're going to sketch 2 periods of y is equal to, this one, it looks crazy, but it ended up being not too bad. Cosine of 1/2 x plus pi over 2. All right, so look, your new starting point here is negative pi. And then you're going to add quarter periods. So negative pi and a quarter period was pi, is 0. Then 0 plus pi is pi. Pi plus another pi, because I'm adding quarter periods, is 2 pi. And then 2 pi plus another pi gets me 3 pi. And then look, this is how it's always going to work out. This is going to end up, when you plug negative pi into this, okay, you get 1/2 times negative pi is negative pi over 2 plus negative pi over 2. Like, you get 1/2 times cosine of 0, which is 1/2 times 1, which is 1/2. It's always going to work out like that if you do this correctly. So it's negative pi comma 1/2. This ends up being y is equal to 1/2 times cosine of pi over 2. And cosine of pi over 2 is 0. So this is 1/2 times 0, 0. So my next test point is the point 0 comma 0. Pi. This ends up being 1/2 of cosine of 3 pi over 2, right, which is negative 1. So this is 1/2 times negative 1, negative 1/2. So pi comma negative 1/2 is my next test point. So when you plug this in, right, you know, I made a little bit of a mistake here. This was pi, sorry about that. 1/2 of cosine of 3 pi over 2, my fault there. Cosine of pi, obviously, a little misspoke there, it's negative 1. That's my fault. Cosine of 3 pi over 2 is 0. So this is 0. So my next test point is 2 pi comma 0. Sorry, I really apologize for that error there. And then finally, when you plug 3 pi over 2 in here, you get cosine of 2 pi. So this is 1/2 times 1, which is 1/2. The point, though, is, I got a little confused there, is you need to go 1, 0, negative 1, 0, 1. Always, always, always. So this is 3 pi comma 1/2. Okay, now remember what I asked for this in this, though. Okay, I asked you to sketch two periods, and then again, sorry for that, little typo mistake there. When you record these lectures, sometimes you make a little error. But anyway, so we got it. So we're gonna go start at negative pi, go 0, pi, 2 pi, 3 pi. So we're gonna sketch two periods of this y is equal to 1/2 times cosine of 1/2 x plus pi over 2. So remember, we're going to start at negative pi. 0, pi, 2 pi, 3 pi. So that's 1, 2, 3, 4, 5. Okay. And then you want to sketch two periods. So then you're going to need 4 more points. So 4 pi, 5 pi, 6 pi, and then 7 pi. And remember, this is going to go up to, here's 1/2, here's 1. We're only going to go down to negative 1/2 here. So look, how does it start? 1/2, 0, negative 1/2, 0, 1/2. So 1/2, 0, negative 1/2, 0, 1/2. And then what's going to happen? It's going to repeat itself. So 0, 1/2, 0, 1/2. And we got it. Okay. One last quick thing to work through. And again, you're going to get a lot of opportunity to practice this stuff. But I just want to now just really quickly talk about a vertical shift of sinusoidal graphs, okay? for sinusoidal graphs of this form, y is equal to a times sine of bx minus c plus d. So you're adding some value here, okay? Or y is equal to a cosine of bx minus c plus d, okay? Whenever you just have a plus d on the outside, all it does, this constant d causes a vertical shift. So if it's positive, you're going to move the graph up. If d is negative, whoop, you're going to move the graph down, okay? So all it does is these vertical shifts result in sinusoidal graphs oscillating about the horizontal line y is equal to d rather than the x-axis. That's it, okay? And so the maximum value is d plus the absolute value of a, and the minimum value is d minus the absolute value of a. So I just want to do one very, very quick example for this, okay? So let's sketch the graph. Let's do this one. Y is equal to cosine of 1/2 x plus 2. And let's go from negative 4 pi to 4 pi. Okay. All right, look, you see how you have this plus 2 on the outside? This tells me that there's going to be a vertical shift. All right, so there's no value in front here. So my amplitude, so my A is 1. This is my B, which is 1/2. And there's no C, so that tells me there's no vertical shift. All right? So let's just go through. Let's do the same process. Amplitude is equal to the absolute value of A, which is just absolute value of 1, which is 1. But this is going to mess with the period, okay? This is 2 pi over B, which is 2 pi divided by 1/2, which gets me 4 pi here. Next, we have a quarter period. So you take this 4 pi and divide it by 4, and you get pi. And then what you can see here is there's no phase shift. But there is a vertical shift. So this plus 2 tells me a vertical shift. All right, so we have a vertical shift because it's positive up 2 units. All right, so again, you're going to find the 5 key points. All right, so no phase shift. So you are going to start at 0. And then you're just going to add quarter periods, right? So then you add 0 plus pi gets me pi, then 2 pi, then 3 pi, then 4 pi. Now look, when you plug this in, right? When you plug 0 in, cosine of 0 is 1. So you get 1 plus 2, you get me 3. So 0, my first point is 0, 3. Now when you plug in pi, cosine of pi over 2 is 0. So you have 0 plus 2 gets me 2. So my next test point is pi, 2. Here, 1/2, and then times 2 pi is just pi. And so cosine of pi is -1. And then don't forget you have this plus 2. So it's 1. So when you plug in 3 pi, all right, you get 1/2 of 3 pi is 3 pi over 2. Cosine of 3 pi over 2 is 0. And then 4 pi, 1/2 of 4 pi is 2 pi. So cosine of 2 pi is 1. And look what happened. You're just 4 pi comma 3. You're just moving, instead of being 1 0 negative 1 0 1, you're just moving all those values up 2. So that's really all that you did here. Okay. And look what's going to happen when we sketch this, right? So first off, we see the maximum value is 2 plus 1, which is 3, and the minimum value is 2 minus 1, which is 1. So max is 1, or max is 3, minimum is 1. And you're going to notice that it's going to be oscillating around this line, y is equal to 2. And you'll see it when I graph it. All right, so we want to sketch the graph of y is equal to cosine of 1/2 x plus 2 on negative 4 pi to 4 pi. So my points were 0, pi, 2 pi, 3 pi, and then 4 pi. And then we're going to go down to negative 4 pi. So we're going to do the same thing. So negative pi, negative 2 pi, negative 3 pi, negative 4 pi. So 1, 2, 3. So look, 3, 2, 1, 2, 3. So 3, 2, 1, 2, 2, 3. And then it's going to be, because it's an even function, same thing on the negative side here. So 2, 1, 2, 3. And look, it's oscillating here. If I were to draw this through y is equal to 2, as I said, look, it's oscillating through that instead of the x-axis here. All right, class, I know there's been a lot in these last 2 lectures, and they've been long, and they've been very, very long. But you'll get a chance to practice this, and as you do more and more, these will become easier and easier. And as always, I'm here if you need anything.